Hello everyone, I'm Xiao Gang. Okay, next, we'll write about what we need to do after a successful connection. We still have some work to do before we can properly receive this information. Okay, after a successful connection, this pointer must definitely exist. Of course, it should exist. If it doesn't exist, none of this work can be done. So, if it does exist, we'd better give a log or a check. Let's just give a word like this. Generally speaking, it does exist. This is a habitual practice, because sometimes you're not quite sure about the situation. Next, we'll create this connection of ours. We mainly wrapped a layer around this thing. Okay, let's take a look at this part. Is it that we haven't included the header file here? It looks like the header file hasn't been included. So we include the header file like this, included at this position. This header file, it should be. Okay. Good. After we include this header file, there will be no more errors here. Good. Then we have created our serial collection, and then we set this state. That is adjusted to a state of waiting for the client to deserialize. Because actually at this point, only after the client enters, we have passed the authentication. We still need to wait for the client to send the first message. So we are adjusting to this state, and I have a piece of code here. Copy it over. I have commented out this code because I found that this code is currently not correct. When testing earlier, it did not trigger a corrector, so we can just ignore it. That collected code band thing, don't worry about it. And then we need to prepare an incorrect area code band. Area code band is it. That is to say, if an error occurs here, it will actually be here. You can take a look. This area command, is it? You can see. That is to say, it all uses this info command. An error occurred. So here, we bind a practice to it. Then we bind it to this area command, this method. Then we pass this delegate into it. So this side is the payload loaded. Because we need to match this serial connection to this ID, because here it is created during construction. Through it. Okay, now let's create this method. We'll write this method below. We'll just paste these 4 methods directly. Just paste them directly. Okay, you can see they are all relatively, because the information here basically matches it. We'll just create it directly. Let's create it first. Next, we'll explain what these methods do. First of all, we didn't use this connect band because this connect band actually means it was never called or executed. It's very strange right here. So let's ignore it for now. Then we mainly look at this error topology. As for the error topology, actually it mainly handles this link input error, because if the input is wrong, it simply cannot connect. So we just do it like this. Just write it. This is the most important part. We have received the information. This extension, it refers to this. It will give you the customized data. And then here, we will handle the reception. We won't process it for now. Not processing it for now. Then we inject the callback into it. And here it is, close Koban. That is, when we close it just now, it will give an ID. This ID is all. Here we go, into the composite, because you will find it actual last time info Koban. It has no information. So we do this. We make it easier to identify the context, because we may have multiple such connecting on it. So we just do this. Give it a say. After doing this, we need to, the link we created, we have already initialized it. We put it into our container because we will process it further inside the container. As for this container, we will declare it in this header file. We will make this container a tapback. That is, it is differentiated by this selection ID. You can see when we add, we put the selection ID here, and then we use a move temp here. Because this thing, that is, this pointer, we can only let one instance of a struct hold it. We do not want 2 structs to hold the same instance, so in the end, we make it move temp. Okay, after this is done, we need to log a date here. That is to say, actually, in this place, it is equivalent to having completed this. A project created through this link. Okay, good. So next, we will write the content inside these 4 methods. Then we can perform this kind of test. Okay, when writing this, we need to define several delegates. First, regarding these delegates we define, I will call them over. and explain to everyone what each one is used for. Everyone can just call them directly, no problem. This one is a delegate for successful connection. Then this is, that is to say, connection failed. Yes, and this means a message has been received. So these ones are closed. Then these agents are all exposed for use in Blueprint. Therefore, here, we need to instantiate them. Because we need to facilitate binding and usage in Blueprint, this should be quite familiar. So placing it here should be fine. Okay, after we finish writing it, we need to compile it. Maybe need to have it generate some code. Maybe it doesn't have this information yet. Okay, there's still an error here. If there's an error, it's probably because we didn't include the header file. Let's put the header file here. Let's move the header file out from here. Let's compile again. Okay, that should work. This doesn't need an export either, because the external code won't use it. Should be fine. Okay. Then after we succeed in building, now we need to think about the trigger timing of this agent. Then we just go one by one and write these form agents in this position. Next, let's rate the connection success. But you need to note, this connection success is something we need to handle. You will notice why we commented it out here, because the actual connection success is not just that the creation was successful here. But connection success must follow our process only after the client sends the information. Do we consider the connection successful? So you need to know that here we have made a special handling. So when it connects successfully, as you can see, it has connected successfully. Then we need to print a log here. That is to say, this current connection is successful. Okay, then I need to bring this proxy over. This proxy, as for the definition of this proxy, actually there are two of them, that is the client and the server. Because only after the server sends the message, do we have the server's ID? Then we can just execute it in one step. Okay, pay attention to this call timing. It is not called particularly early. It's timing. It is deliberately delayed by us to be called. In this error coding case, it can be used normally. That is, if an error occurs anyway. This allows the underlying web server to adjust this timing. Then we can know which connection has an error. And as for receiving this information, we won't write it for now. Not write it for now. We'll just write the close part. So when we close, we need to close it. Then we can know that this connection is probably closed. So because this connection is closed, right, we need to release the specified resource. So this is to remove the server connection resource from our container. Therefore, we need to write this removal method. So we write the removal method a bit higher up. We write it in this position. This is also a protected method. It only needs to pass in a server connection. Remove it from our container, then release it. You can release a specific one. You can also release all of them. So we wrote both things together here. Okay, let's switch back. So how do you release a specific one? Actually, this is how we release a specific one. First, we find this. Find this, right. Find our ID. If this thing exists, then its number should be equal to 1, right? That is, we remove it. Then it is successfully removed. Then we prepare on our end. We close this proxy. Then we let it pre-execute. You will find that here. Actually, regarding its native thing, we have wrapped a layer around it. Okay, we wrapped a layer through this place to let it. Only at this time do we call back to the blueprint to tell the blueprint that a connection has been closed on our end. So actually, when you release resources, when it is released, it is through this struct destructor method to release the actual resource. Because here we are in this destructor function, you remove this object and it gets removed. Then releasing all of them is very simple. We just need to iterate through all these resources, and then call their respective. Find all the ideas, and then we call all of these in the next week. Then after we finish calling directly here, we can just call empty. Okay, because it will be called in the next frame. This part is just equivalent to turning this thing into an asynchronous task to be called in the next frame. And then actually, we will release it in this frame next after processing it this way. Then we execute this method of receiving, because this method of receiving information is quite complex, we need to further encapsulate it in multiple layers. You will notice that this part has not been called yet. The timing of the call here, we haven't written it yet. Note that it hasn't been written yet. Okay, then we will write it later. And at this point, we receive the information. Then we need to process this information. First, we decode this information. Decode it into our because it is base 64. It is a base 64. We decode it. After decoding is complete, we convert this information into our such a connection. Okay, actually, here we need to print a log. Let's set up the listener. Let me see if this log can be copied over and used. It should be possible. Change this log. Okay, this part corresponds to these. This information should be it. This is our base 64 information. Yes, after we decode it, after decoding it is a JSON, then this JSON can be converted into a struct. Normally this struct should definitely exist. Right, so first we need to make a judgment. First, this struct, it must exist, and its code must be 1. If this struct comes in and it is not correct, then it won't work. That is, we directly close this connection, indicating that it is not a connection sent by our client. Possibly the version number is incorrect, or someone else forged this information. We directly terminate it. Then we log this. Actually, regarding this kind of log, should give a slightly higher level of this log. It is invalid. Then we close this current link. If we pass it here, let's take a look. This link should be just close the specified link. Take a look. Here, okay, let's see if we wrote this before. Actually, the most important thing is this. Okay, because we need to encapsulate this method. Because this method is actually on our client side. We will also call it, so here we have wrapped a layer. Actually, we most likely cannot call this method because the information here is wrong. It may be caused by other reasons. So we cannot simply close it here because we might need to send a message to the client to let them know about this issue. So let's not write it this way for now. Delete it for now. Okay, let's first ensure we are correct. Then next, we can proceed to do a simple test like this when we receive this information of ours. After we hit the WebSocket server, then we go through Postman. To send this message, we can then, at this location, receive this message. Because logs will be printed here, but this struct here definitely cannot be parsed because we might need some testing methods. Then let's first stop here for now. Then in the next episode, after we pass the test, we will continue further. Go finish it. Okay, thank you everyone.